Hi everyone. We're just going to go over some of the topics for exam one. So let's start with the first thing that we learned about. You have something called a function. Now, the one way of representing a function is as a machine that takes an input and gives you an output. Okay, and we call this function, we use the letter f to denote the function. To denote the input, we use the variable x, and to denote the output, we use the variable y. So, when we say y equals f of x, what we mean is that if the input is x, then if input equals x, then the output is y. Now, this is true for something like, say, example, your smartphone. Right? You have a bunch of buttons. When you press a button, something specific happens. And you want the output to be specific. Now, um, again, going along with the input, the set of valid inputs, that's called your domain. And then the set of valid outputs, that's called your range. Now, that's one representation of a function. Then there is another representation. Let's call this A. B is algebraic. So here's where you would see x and y, etc. So for example, if I say y equals x squared plus 1, okay, or this can also be written as f of x. Now I can find the values. This is called, I can evaluate the function. What that means is finding out what the output is for various input. So for example, f of 0, what you do is you replace x by 0 and you see what the output is. Similarly, f of 1 would be 1 squared plus 1, which is 2. Now I can plug in any input. I can ask you what f of a is, and you just replace x by a. And in this case, you leave it as a squared plus 1 because it's not a number, so you cannot combine them. Okay. There is another representation which is called graphical. So sticking with the same example, f of x equals x squared plus 1. What you can do is you can plug various values of x, find out the corresponding values of y, something like this. And if you do it for a sufficient number of points, you can plot a graph. Now on the graph, the y goes on the vertical axis and the x goes here. So what we have here is something that looks like that. Now, how to reading domain and ranges. Let's say you're given this graph, and you know this is 0, and let's say this right here is 2, and this is 5, and this is again just 0. If you look at these values, that's going to be your domain. So domain here is 0 to 2 included. And if you look at these values, that's going to be your range. And that is 0 to 5 both included. Okay, so you just read off the graph as to what exactly you're looking for. Okay. Now, finding domain algebraically. So when we say valid inputs, So we need to make a list of what's an invalid input. What's an invalid input? So based on the functions that you know so far, you have two scenarios. One is division by 0. That's invalid. And the second is square root of a negative number. So for example, let's say my function f of x is 3x minus 1 over 5x plus 3. And the problem is find the domain. So what we want is we do not want division by 0. So we do not want this to be equal to 0. And now you solve. Subtract 3. You have 5x equals negative 3. Divide by 5. You get x equals negative 3/5. So what you're saying is x can be anything but not negative 3/5. So one way to write that is x is all real numbers except negative 3/5. Another way to write that is in interval notation, negative infinity to negative 3/5 union negative 3/5 to infinity. So this makes sure that negative 3/5 is not included. Let's look at another example. Let's say now I have f of x equals 2x minus 3. Now this is a square root, and this is a 2, doesn't look like 2. What we need is we need that 2x minus 3 should be positive, but it can also be 0, right? Because square root of 0 is just 0. So we solve this using the inequality methods that we have learned. It's pretty much the same as solving an equation. Add 3, divide by 2. So x is greater than or equal to 3 over 2, or x is 3 over 2 to infinity. And that's going to be your domain. Okay. The next topic was solving linear equations. So the first case is two variable. So let's say you have 2x plus 3y equals 7 and 3x minus 2y equals 5. So we're going to use the process of elimination. I noticed that there's a 2x here and there's a 3 here. So what I think is, well, if I multiply 2 by 3, I get 6, and I multiply 3 by 2, I get 6. So the goal is to have the same number. So that's what I'm going to do. You multiply this whole equation by 3 and this whole equation by 2. Again, you have to multiply everything in order to preserve the equality. When I do that, I get 6x plus 9y equals 21, and I get 6x minus 4y equals 10. And the reason I want the same number is so that now when I subtract, the x terms cancel out. A tip here, when you subtract, you can use parentheses to write the new signs. So subtraction of positive becomes negative, negative, negative becomes positive, and so on. So you get 13y equals 11, and you get y is 11 over 13. But you're not done. You need to plug this back into any one equation. So what you get is 2x plus 3 times 11 over 13 equals 7. You multiply to get 33 over 13 equals 7. Now to solve, you subtract 33 over 13 from both sides, and you get 2x equals 7 minus 33 over 13. which if you do the common denominator stuff is going to be 91 over 13 minus 33 over 13. You end up with 2x equals, it's 91 minus 33. That's 58 over 13. And eventually you get x is 29 over 13. So your solution is 29 over 13, comma, 11 over 3. Now let's look at three variable case. Three variable case, you have, say, 2x minus y plus z equals 3, x plus y minus z equals 2, and 3x plus 2y plus z equals 7. Now in this case, we're going to repeat what we did for two variable, but we have to do it 3 times. So first, I'm going to look at these two equations. I'm going to copy them here. And I notice that it's kind of easy to eliminate the z, because if I just add them, if I add all of these, the z gets cancelled and I get 3x, actually the y gets cancelled too, equals 5, giving me x equals 5/3. Now I take these two and I rewrite them. I have x plus y minus z equals 2, 3x plus 2y plus z equals 7. I add them, these get cancelled, and I get 4x plus 3y equals 9. But I already know what x is, so it's 4 times 5/3 plus 3y equals 9, which gives me 20 over 3 plus 3y equals 9. And I subtract 20 over 3, subtract 20 over 3 to get 3y equals, let's call it 27 over 3 minus 20 over 3. 3y is 7/3, giving me y is 7/9. Now I have the value for x and I have the value for y. I can find the value for z. So I have 2 times 5/3 minus 7/9 plus z equals 3, and I can solve for z. And the three variable case, the three variable equations, there are 3 possible scenarios. One is you get one unique solution. So in this case, that's the example we looked at last time. The second one, you would get a no solution, and that is if you end up with something like 3 equals 0. Okay, when you're solving and you end up with something like 3 equals 0, it means there is no solution. And the third case you have is infinite solutions, and this happens if you end up with, say, 0 equals 0. Okay, when you are solving something. So that's it for exam 1. Go over the online stuff and some of the things that I've posted on Lovelyma, and you should be good.